Welcome to this short tutorial on data import in the drEEM toolbox. First of all, before I get started, I should mention that you can find this very tutorial and the code behind it in the documentation of the toolbox. So if you type drEEM in the MATLAB console, you'll be greeted by a website that looks like this. And I've already pre-selected under the tutorials section the simple data import tutorial, and you can see here there is available the formatted version of the tutorial that we're going through. And the very first step is to open the tutorial in MATLAB, which is what I'm going to do now. So if I go to MATLAB and select my tutorial here, you can see that I don't have any workspace variables or any code in the command window. So the tutorial as it's laid out here gives you a short overview over what's in the tutorial and then continues down the line. So I'm just going to run through this tutorial here. First of all, you can see that we're setting up the toolbox by clearing all the variables and closing all windows and even forcing to close all windows so that we start with a clean slate. Then we change to the directory that this tutorial is in. So we can select these lines, right click and say evaluate selection, and you will see that now we've changed the directory to a directory in the drEEM toolbox path. And next we initialize the toolbox by assigning it an object. Toolbox in this version is object oriented. That means that we assign an object to the toolbox, which allows us to access its functions and get nice suggestions. So for example here, tbx dot, and you can see that is the object. By typing dot, you start accessing the object and see its properties and methods. Good. So now we have the toolbox set up and we can start by importing the data. Here we have, for simplicity's sake, we have some samples that were measured on a Reba Aqualog, which has some nice advantages to it in terms of simplicity of data collection and exporting from the software. So to start, we simply change into the directory where this data is stored. So here in the file explorer of MATLAB, you can now see a lot of different plots or files appear with different plots. And in the next line, we already complete the import of the EAMs. In this case, we want to import the files that are tagged by this, this set of characters here, waterfall plot sample.dat. All of the samples that end in this extension will be imported by the toolbox now. This method, import EAMs, and its default options are set up in a way that works with the Aqualog. This is just a default instrument of a lot of people these days. As you can see in the background, a lot of importing has happened. So we have about 33 samples here. And when the import EAMs function was finished, a change status graphical user interface or GUI appeared here that says, this is a new dataset. You should tell me about its status. You can see that we have a lot of different items. Currently, the toolbox knows nothing about this dataset. You can get help by clicking this help button here to find out what is actually meant by this kind of item here, by the status item or the step item. We have spectral correction, for example, or blank subtraction. And as it so happens, this status, as suggested in the new status column, is correct for this particular instrument. For example, the spectral correction has happened in the instrument software, so you would say applied by instrument software, whereas no inner filter effect correction has happened, no blank subtraction, no fluorescence calibration, and so on and so on. And the absorbance in the Reba Aqualog is of course an absorbance per 1 centimeter. That's the path length. To finish the import, you say save and exit. And now we have a sample data set. You can even type samples in the console. And you can see there are a lot of properties. For example, the fluorescence, the excitation wavelengths, the emission wavelengths are all imported. If you want to find out how this function import eames works in your particular case, you would type doc import eames, which I'm not going to do now, but you'll be greeted by the detailed documentation of this function that'll help you to get started if your options won't work in the particular case. This now has imported all the samples, but there are of course also blanks, which we import in the next line here. We run through this. Same thing happens. All the samples get imported, or the blanks get imported, and the toolbox wants to know about the status of the blanks, which is exactly the same as for the samples. So we can simply hit save and exit. And now we have samples, fluorescence samples, and fluorescence blanks imported. Next, we import the absorbance. The Ariba Aqualog measures samples, blanks, and absorbance in this kind of format. And so we can simply hit evaluate this selection. And what is created is also, in the case of absorbance, a drEEM dataset, which just doesn't contain any fluorescence and only absorbance, whereas the fluorescence datasets only contain fluorescence and no absorbance, even though the dataset itself is in the exact same format. So here it's important to specify absorbance per centimeter, which is already done by default. So we say save and exit. Now we have 3 different objects. They're all of the class drEEM dataset. You can learn all about that object by accessing the documentation in the toolbox. Then we change the directory back to the parent directory so that we're back to where we belonged. So I'm scrolling over this just to demonstrate that actually there was a spelling mistake in one of the samples. And some other things that are particular to the Ariba Aqualog can be fixed now. We can, for example, erase the parentheses 0 or 1 that occurs after every single sample, as you can see in the import output here. This is information that comes out of the instrument software by default, but it's not really required to have this kind of string in there, so we can simply erase that from the samples, the blanks, and the absorbance file list. And we can then add a comment to our dataset that says we've done that, in the interest of transparency and sort of traceability. Next, we need to make sure that everything is aligned. We've now imported fluorescent samples, blanks, and absorbance scans separately. But what if one of the files was missing or something else was up, maybe a spelling mistake in one of the file names? And for that, we have a function here called align samples. Again, you could type doc space align samples to learn all about that function. What it does is it compares all the file names in every single dataset it is supplied. And you can see that if you run this function without an output in the console, you find out that it is run in diagnostic mode. And that means that you don't supply, when you don't supply an output argument, nothing is done other than the function is run in a mode that doesn't have any consequences for your workspace variables. And in this case, you actually get a visual output. And that is a list of all the file names, as you can see. And you can see that one of the files is marked in red because there is no absorbance scan. There are fluorescent sample scans and the blank scan, but no absorbance, which means that this sample would be deleted if this function would actually run. It's very likely that the absorbance scan just went missing. So if we now run this function with output arguments supplied, you get the same output except for the hint that there's no diagnostic mode run here, and the input arguments actually overwritten in the output. That means that the absorbance dataset is now one sample, or the fluorescent sample and blank dataset is now one sample less than it was before. in order for everything to be aligned. And there's also a reordering of the samples that occurred if that was necessary, so that the samples in all of those data sets are now fully aligned. Next, we transfer the absorbance to the sample data set simply by carrying over the information. Now that sample alignment is taken care of, we just need to transfer the wavelength information and the actual absorbance scans. That's these two lines. And just to be sure that everything worked, we can actually validate the data set that resulted from this operation. This is making sure that everything is aligned properly and no misalignment in terms of wavelengths or number of samples in any of the variables is occurring. Now we can get rid of the absorbance dataset. It no longer serves a purpose, and we can leave ourselves a hint about this operation having taken place in our resulting dataset. If we have metadata, we can now associate it with the sample dataset. In this case, we do have some metadata. We can find it here by scrolling down in the File Explorer all the way down to metadata. You could open this outside of MATLAB and you could find out all about this Excel file and what it contains. Important to know that in this metadata table, there is a column called sample ID, which matches perfectly with the file list information in our fluorescence sample dataset. And this is what's being compared between the Excel file and the drEEM dataset to output the metadata that is to be associated with our dataset. This can be found in this variable here. So if I say samples.metadata after performing this or using the associate metadata function, you can see that the table now contains a lot of metadata information such as location, latitude, longitude, salinity, and so on. Now, after the import is sort of almost complete, we can see what has actually happened to the dataset. You can say display history. This shows in the console a short description of the functions that have been executed on the sample dataset and a function message that contains interesting information if you want to go back and understand what's happened. This also contains your own user comments about erasing a string pattern or the transfer of the absorbance from the separate absorbance dataset into the sample dataset. You can also get this as a visual output in a graphical user interface called View History, which actually makes accessible some of the options. So you can see here, for example, the import eames function. Even though we didn't supply any input arguments, it has default input arguments such as column wave, row wave, column is excitation, the number of header lines. These have all worked out in our case with the standard default options, but if you need to change them, you could find the options here so that you know what has actually happened without having access to the original script necessarily. So we can close this. And that is basically the end of this tutorial. The last thing to do is to save the files. And then in the next steps, processing of the data, we could load this file. We wouldn't have to repeat the import. We could simply load this file and start from there without having to do the initial importing steps again. That's the end of the tutorial.